Hello guys, so we are back again, and in this session we are going to continue with some more questions on Euler's theorem for three variables. The first question which we are going to take is as follow. But before starting with the session, hope you have subscribed this channel so that we can bring more engineering content for you guys. Now with that said, let's begin with the lecture. The question is as follow. If u equals to x square, y square, z square, the whole upon x square plus y square plus z square plus cos inverse x plus y plus z, the whole upon under root x plus under root y plus under root z square, find the value of x dou u by dou x, y dou u by dou y, z dou u by dou x, dou z. You know that this I can prove by simple harmonic function. And in the starting lecture I told you, when you use reduction, when there is cos inverse, log and sin inverse, this type of thing, so you get an idea that here I should use reduction, so you know what you have to do. So let's do it. First you have to write okay. So we have written this under root x, under root y, under root z. After doing this, let v equals to x square, y square, z square, x square, y square plus z square, w equals to cos inverse x plus y plus z, the whole upon under root x, under root y, under root z. Now what we are going to do, first we will take this, put v is equals to x is equals to lambda x, y equals to lambda y, and z equals to lambda z in v x y z. So v lambda x, lambda y, lambda z will be equal to, here we will get lambda power 6 x square y square z square, and here we will get x square plus y square plus z square, the whole upon, okay, the whole upon lambda power 2. So this will nullify and you will get lambda power 4 v of x y z. So v of x y z is a homogeneous function of degree n equals to 4 in variables x, y, z, right? Now by Euler's theorem I can write x dou v by dou x plus y dou v by dou y, z dou v by dou z equals to what? It will be 4 times v, which I will call it as a. V is what? This thing. Now what we are going to do in the next is, let, we know how we have to solve. We have to solve this by deduction. What we are going to take the cos this side, so it will become cos w equals to x plus y plus z, the whole upon under root x plus under root y plus under root z. What you have to do, equals to h x comma y comma z. Put x is equals to lambda x, y equals to lambda y, and z equals to lambda z in h of x comma y comma z. Then you will get h lambda x, lambda y, lambda z equals to, here you will take lambda outside, x plus y plus z. Here you will take lambda power 1 by 2 outside, which will give you under root x, under root y, under root z, lambda power 1 minus 1 by 2 into what? h x comma y comma z. Lambda power 1 by 2 is h x comma y comma z. So you got h x comma y comma z is a homogeneous function of degree n equals to 1 by 2 in variables x, y, z. Now we know that what we know, cos w is nothing but h of x comma y comma z is nothing but f of u. So by wait, so now you have to write, now f dash u is nothing but d by du of cos w, which is nothing by minus sin w. right? By Euler's theorem, what we have by Euler's theorem is that x dou u dou w by dou x into y dou w by dou y into z dou w by dou z is equals to n times f of u upon f dash u, which is nothing but here n is what, 1 by 2 1 by 2 into what, cos w the whole upon minus sin w, which will give you minus cot w by 2, which is our b. If you open this, now you have become smart enough that it will come out this thing only, this and this summation. So add a and b. You can write that step automatically because you have done so many problems. Now you are smart enough that I can guarantee that you will write this thing. Okay, open and write that. So I leave that thing to you. So finally you are going to get x dou v by dou x plus y dou v by dou y, z dou v by dou z plus x dou w by dou x, y dou w by dou y, z dou w by dou z will be equal to minus cot w by 2 plus 4 into what? 4 into what thing it will be? It will be x square y square z square the whole upon x square y square plus z square. So we got this thing. Okay, so we are done with this problem. Hope you had understand each and every step. Okay, so now let's move on to the next question. So the next question which we are going to do is this question, which says if v equals to log bracket sine 1 by 2 2x square plus y square plus xz the whole upon 1 by 2, in the denominator x square plus xy plus 2yz plus z square the whole upon power 1 by 3 bracket close. Okay, and that the second bracket also closes. Prove that x dou v by dou x plus y dou v by dou y plus z dou v by dou z equals to 1 by 3 e power minus v under root 1 minus e power 2v sine inverse av. Here you can see it is log something like that, so you get an idea that what you have to do. You have to go with the what, deduction theorem. V equals to, you have to first write this thing, xz the whole upon x square plus xy plus 2yz plus z square the whole power. Here it will be 1 by 3 and here it will be 1 by 2 bracket close. I will move it here, it will become EV. I will move this here, it will become sine inverse EV. Okay, hope you have understand this step properly. Now we are left with 2x square y square xz the whole upon 1 by 2, in the denominator x square xy 2yz z square power 1 by 3. What we are going to do? We have to consider it equal to some, let h x comma y comma z. The moment you do that, put x is equals to lambda x, y equals to lambda y, z equals to lambda z in h x comma y comma z. You will get h lambda x lambda y lambda z equals to pi by 2 bracket, you will get lambda square, and if we move out outside, will be lambda only, and here you will get lambda square by what, 3, and this will be as it is 2x square plus y square plus xz the whole power 1 by 2 into x square plus xy plus 2yz plus z square power 1 by 3. This whole thing with pi by 2 I can call it as h of x comma y comma z. So I am left with lambda power 1 minus 2 by 3 the whole upon h x comma y comma z, which gives me finally lambda equals to 1 by 3 into h x comma y comma z. So h of x comma y comma z is a homogeneous function of degree n equals to 1 by 3 in variables x, y and z. We know that, what we know that? We know that that this thing sine inverse EV equals to h of x comma y comma z is equals to f of u, right? So f dash u will be nothing but 1 by under root 1 minus EV square into e power v, right? E power v. So we are getting everything proper. Now we got what we wanted by Euler's theorem. We can say x dou v by dou x plus x what is this? This is nothing but what? Dou v by dou x, right? This entire function is dou v by dou x. So we can write this dou v by dou x equals to y dou v by dou y into z dou v by dou z equals to n times f of u upon f dash u. So what you are going to substitute here? 1 by 3. F of u is what? F of u is sine inverse EV. So here sine inverse EV. Now what you have to substitute in place of this? You have to substitute 1 by under root 1 minus 2 EV, which will on the top 1 minus e power 2v. In the denominator e power v, which if I move it up will become e power minus v. So hence you can clearly see that we have proved it. Hence proved. So it was an easy question. Hope you have understood each and every step. I have skipped some basic steps so that we have came to the end of the chapter, and the questions are quite lengthy, so I don't want to extend the video because which will cause you boringness. Okay, so avoid that to keep your mind fresh. Okay, I am reduced the steps which you can step, and these steps I have already did in the starting only. Okay, so you should have become habitual of doing this. Now let's move on to the next question, which is this question. If u equals to cos bracket xy plus yz the whole upon x square plus y square plus z square plus sine under root x plus under root y plus under root z, find x dou u by dou x plus y dou u by dou y plus z dou u by dou z. Now this function you can directly say I will go with the simple Euler's theorem, but this you cannot go with the deduction, nor you can go with the simple one. Why? Because here you can know it is not a homogeneous function only, it can never be, because lambda power 1 by 2 will come here, will not move outside of the sine. Okay, so what should we do? Here we have to go with a simple approach and consider it a simple function and differentiate it and get the answer. That is the normal way, okay, which we have in which we have did the questions of the starting, okay, when we started the chapter. So what you have to do? First you have to write whatever it is given. This thing clear? What you have to do? Let v equals to cos xy yz x square y square z square, right? And w equals to sine under root x under root y under root z. After doing this step, what your next job is? Put x is equals to lambda x, y equals to lambda y, and z equals to lambda z in v x comma y comma z. Here lambda square will come outside. Here also lambda square will come outside, and you can make out it will become lambda power 0. So which we can write as lambda power 0 into v of x comma y comma z. So v of x comma y comma z is a homogeneous function of degree n equals to 0 in variables x comma y and z. Now by Euler's theorem, since we are not going with the deduction theorem, we are going to directly write by Euler's theorem x dou v by dou x, y dou v by dou y, and z dou v by dou z, which will be nothing but. So what we are going to do after writing this, it will be what? N times whatever the degree is, which is 0, times v, which will be 0. So let's call it a. Now what we are going to do, we are going to write here. We know we cannot go with the homogeneous way, so we have to go with the simple way. Find dou w by dou x, dou w by dou z, dou w by dou z, okay, all the three components, and multiply it and then substitute it in the end. So partially differentiate w with respect to what? X. So dou w by dou x is nothing but what you are going to get. This is sine, so it will become cos under root x plus under root y plus under root z, the whole upon twice under root x, multiplied throughout by x. We get x dou w by dou x equals to, if I multiply it with this thing, what I am going to get? Under root, we will get x by 2 under root x into cos under root x plus under root y plus under root z. Simple thing. And if I rationalize, I am going to get under root x and under root x. If I divide and multiply, I am going to get cos under root x under root y under root z, the whole upon under root x by 2. Let's call it sum 1. After doing this similarly, what we can write? Y dou w by dou y will be nothing but under root y by 2 cos under root y plus under root y x plus under root y plus under root z. Call it 2. And similarly, z dou w by dou z is nothing but under root z by 2 cos under root what? X plus under root y plus under root z is equals to 3. Now what we have to do? What you have to do? If you see the proof, what do you have? X dou u by dou x, y dou u by dou y, z dou u by dou z. So x dou u by dou x, y dou u by dou y, and z dou u by dou z, which I can write as x dou u by dou x v plus w, y dou u by dou y v plus w, and z dou u by, which I will write as v plus w. If I open this, we are going to get x dou v by dou x, x dou w by dou x, y dou v by dou y dou w by dou y, z dou v by dou z, and z dou w by dou z. So here we are going to, if I add all of these three, I am to get this value, and this value I have, and this 3 value I already have as a. So if I substitute, this value is 0 and this all value is what? This value is under root x by 2. Right? From what? 1, 2, 3 and a. And here I will take what? Cos under root x under root y under root z common. I will be left with final thing, which is nothing but 1 by 2 under root x plus under root y plus under root z. So which you can write, okay, sine inverse v. Okay, so we are done with this problem. This is the value of the required thing, hence prove. So we are done with this chapter, partial differentiation, and in the next session we are going to start with the maxima and minima. So this chapter was lengthy. I know you need to practice a lot, then only you will understand this chapter, and this chapter is also important for GATE, and we have covered everything as far as GATE and as well as far as the engineering college examinations are concerned. See you in the next lecture. Revise this question and don't forget to share it with your friends. We put so much effort to bring these questions. Okay, solve it in a proper way. Okay, so please subscribe the channel. Thank you.